y equals 2x minus 1 over x squared. Again, the function has been given to us in mixed format. Here's the quotient, here's the remainder. That will help us to work out the asymptote. Can you see what it's going to be already? Remember, this is actually a cubic function hiding in disguise. It's actually, multiply this term by x squared, 2x cubed minus 1 over x squared. So, ideas. For the y-intercept, set x equal to 0. Normally a comma, don't know why I put a colon there. Intercepts, y-intercept x equals 0. I've got a problem, I can't divide by 0. Y is undefined. So that's actually going to be a vertical asymptote. But let's find it when I get to discontinuities. For x-intercepts, set y equal to 0. Well, that means 2x cubed minus 1 over x squared is 0, which means 2x cubed minus 1 is 0, which means 2x cubed is equal to 1, which means x cubed is a half, which means x is 1 over the cubed root of 2. Now again, you don't need an exact value for this. Have a rough idea. The cube root of 2 is between 1 and 2. So this fraction then is between a half and 1. That's all the information we need. Discontinuities. The graph is discontinuous wherever the bottom of this fraction is 0. X squared is 0, i.e. x is 0. This is a vertical asymptote. Okay, extremities. As x approaches plus or minus infinity, what's y doing? Well, this term is going to be 0, so this term is going to predominate, and y is going to be 2x. That's an oblique asymptote. Now, it is also worth noting this term will always be positive, and I'm subtracting it. So I'm always going to be below y equals 2x. I'm always going to be subtracting something positive. So I'm going to say here already, from below. My graph more than doesn't cross the asymptotes. My graph will always be below this asymptote. Always below y equals 2x. Let's start drawing a sketch. I have a vertical asymptote at x equals 0. I have an oblique asymptote at y equals 2x. So that's twice as steep as a normal y equals x graph. It doesn't matter if it's not exact for this exercise. Okay, I should probably put an arrow here and an arrow here. Let me label my asymptotes, x equals 0 and y equals 2x. What else do I know? There is an x-intercept at 1 over the cubed root of 2. That's a positive, so that's here. Here, it's meant to be on the axis, my cross wasn't quite in the right place. 1 over cubed root of 2, 0. My function is always below those asymptotes, so it must come up here, have a turning point, and go back down again. And come, no, sorry, below, up here, through there, and up towards that asymptote. Y equals 2x minus 1 over x squared. I would really like to know the coordinates of this turning point. Let's see if I can work them out. 2x minus 1 over x squared. As usual, I'm going to write that with powers of x on the top, x to the negative 2, so I can differentiate more easily. That's 2 minus, no, plus 2 x to the minus 3. Well, that's 0 when 2 equals negative 2x to the negative 3. Cross multiply, x cubed equals negative 1, x is negative 1. Well, that was good. What's y? Y is negative 2 minus 1 over 1 squared, which is 1. That's negative 3. So I can put this point on my graph, negative 1, 3. This turning point here is negative 1, negative 3.